We're going to explain correlation coefficient done by Pablo Jiménez, Víctor de Abajo, Sara Frack, Fátima Antón, and Mónica Vargas. What is correlation coefficient? Correlation coefficient is a statistical relationship between two or more random variables or observed data values, or in other words, the degree of dependence between two or more variables. We also call the correlation coefficient R. There is a general formula, but we also call it the covariance divided by the standard deviation of x times the standard deviation of y. There are different types of correlation. The property is that R must be between -1 and 1. If R is equal to 1, then there's a perfect positive. If R is equal to -1, there's a perfect negative. If it's between 0 and 1, there's a positive correlation. If it's between -1 and 0, there's a negative correlation. And if R is equal to 0, then there is no relationship. First of all, in order to calculate the correlation coefficient, we must find the covariance, which is alpha 11, the sum of xi times yj times nij, divided by the sample size, or also called n, minus the average of x times the average of y, or alpha 10 times alpha 1. Let's explain this with an example. There are two ways in which we can distribute the information in a table to find the covariance. However, to explain the correlation coefficient, we will use this type of table. Imagine we get asked to find the degree of dependence or the relationship between the two variables with this information. To be able to find the correlation coefficient, we must do the following operations. We have to do this table in which we are allowed to find the average of x and y, the variance of x and y, and the standard deviation of x and y. They also allow us to find the covariance, which will be useful to then find the correlation coefficient. We only need the standard deviation of x and y and the covariance to be able to find the correlation coefficient. Our answer is -0.33. This means that they do not present a strong relationship between them. And this is why, because the linear correlation coefficient is near to 0. Now it's time to explain linear transformations. Linear transformation is a change to a variable characterized by one or more of the following operations, either adding, subtracting, multiplying, or dividing a constant or variable. When a linear transformation is applied to a random variable, then a new random variable is created. Linear transformations affect the mean and the variance. Suppose a linear transformation is applied to the random variable x to create a new random variable y. Then the mean and variance of the new random variable y are defined by the following equations. Let's explain this with an example. If we get an employee at Sigma Corporation has a salary of 50,000 and a variance of 1,000,000 to 20,000 euros and a Christmas bonus of $830 and an incentive bonus of 10%, they ask us for the standard deviation. What do we have to do? We have to find y, which is 0.10% times x plus 830. Since we know the variance of the employee's salaries, we can compute the variance of the employee's bonuses from the following equation. 0.1 to the power of 2 times 1,020,000 would be equal to 10,200. The standard deviation of the employee's bonuses is equal to the square root, so the standard deviation would be 101. This means that the correlation coefficient depends on the average and the standard deviation of the two variables. If they change, the correlation coefficient will also change. Hope you enjoyed, and thanks for watching.
Create created using Powtoon.